Good morning to all of you. I welcome you to this session of programming in Python. In today's session, I'll be discussing the concept of lists and I'll be working some programs based on lists. And then I'll be discussing strings in Python with you, right? So just a quick recap of the topic list that we covered yesterday in our class. So we can create list elements using the list class constructor, and otherwise also we can create a list from string or using the range function. Then we have learned that lists are mutable. That means you can alter the lists, and mixed lists are possible. That means a list can contain integers, floats, as well as strings. Then index operator is used to visit the elements of the list. You can have positive and negative index, and traversing can be done with the help of a for or a while loop. Then we learned about list slicing with the step size, then the basic operators and the built-in functions we discovered. Then we learned about list comprehension. That is a shorter way of writing your code with lists. And at the end of yesterday's session, we discussed about list functions. Append, clear, count. The list is there in front of you on the screen. Right? In today's session, I'll be discussing a few programs with you. Right? So let's begin with some of the programs. I've picked up these 4 programs for you. The first one is to find sum and product of all numbers in a list divisible by both 2 and 3. And then the rest of the programs will be working with linear search, with binary search, and with bubble sort in today's session, right? So let me just take you to a Python session here. I'll open the Python IDLE, and I'll open up a program for you. So let's write a program, the first one, to find sum and product of all numbers in a list divisible by both 2 and 3. Right. And what I can do is I can initialize a list here, say a blank list. Okay. And n is the number of elements in the list. N is the total number of elements in the list that I will input. Right. And I'll be using the eval function as usual, right? Otherwise, the input is taken as a string. All right. Then I can use a for loop for I in range n. And I can input some value here. Using a variable x. Right. And I can use the append method to add this element x to the list like this. So this will finish my input for the list L, which I've initiated as a blank list, no elements in it in the beginning. Now I have to find the sum and product of all numbers in this list, which are divisible by both 2 and 3. For that, I can initialize the sum as 0, okay, and initialize the product as 1. Then I can take this variable I, which goes through this list. So for I in L would mean that I can visit each element of L. And then I can use a condition here if I %2 is equal to 0 and I %3 is equal to 0. That is our program. We need to check the numbers in the list are divisible by both 2 and 3. So I'm using this logic here. If it is true, like if it is divisible by both 2 and 3, then I can write something like this. Sum is equal to sum plus I and prod equal to prod star I, right? And then I can print. First I can print the list, okay? Write something like list is, and then I can write L here. And then I can print the sum and product I have just calculated. Similarly, I can take for product also. Right. And save this program and then I can run it. I can store it as say list one in this folder. Right. Then I can run it. So how many elements? Say 5 elements. I can enter the elements. Right. So I've entered 5 elements. So you can see the list. You can see the sum because only 2 elements, that is 30 and 60, are both divisible by 2 and 3. So their sum is 90 and their product is 1800. Okay. So kindly see how we need to write programs on list. We can first initialize an empty list. Then we can populate it with the values like this using the append method. And then obviously we can take some variable to traverse or pass through the list and do whatever condition. Like the main idea, main logic in this is here only. That's it. The rest all is a normal sequence of the programs that you can write with list, right? Next is we can perform a linear search. Okay. Now we missed out something. Okay. We can go with linear search, right? Just put the PPT back in order. So to perform the linear search, like you people have already worked with the linear search program. So I'll just save this file as say ls. Okay. I'll make the necessary changes here. So to perform linear search, all of you try on your own. I'm just writing the program here, but you should be able to do it on your own whenever some problem is given. So linear search means that you want to search for an item, whether it is present in a list or not. Okay, so similar way, I can just do these things again, enter how many elements in the list, right? And then I can populate the list with the values. This will remain the same. Then this will also remain the same. And all I need to do is to input the item that needs to be searched, right? So I can enter the item to be searched. Item to be searched, right? And store it in say variable item. It's simple now. If I'm just going through the list, traversing it, and if item is equal to say I, that means item has been found. So I can put a break here, right? And you see, I also maybe I need to mention the position at which the item is found. So I can take a variable here as position with initial value as 0. And as soon as I'm traversing this list, I can increment this pause, right? Pause is equal to pause plus 1. So if item is equal to I, that means if item matches with some element of the list, I'll just stop this for loop here with this break statement. Okay. So once I'm out of the for loop, okay, whether the item has been found or not would depend on the position of the pause. If the position of pause is yeah, I need to do something here. Yeah. Okay, if item is equal to I need to put something here. Yes. Just a second. I'll just so what I can do is I can take a flag variable k is equal to 0, and when the item is found before I exit the loop, I can set k as 1. So k is equal to 1 would indicate that item has been found. If k stays as 0, that would mean that item is not found. And this pause would keep track of the position where the item is found. And then I'm just left to write this code that if k is equal to 0, I can print say item. You can just write some message here, found in the list. Then I can mention the list here, and then I can just continue the string at position. Then I can mention the position. This way I can just finish off this print statement. And for the else part, that is when k is 1, okay, then I can just copy it here and I can just write here item not found, right? K is equal to 0 is item not found, right? Okay, let's write like this. And I can write here item not found in the list, like this. Okay, so let's run this. And if I put the value of the number of elements is 5, if I just enter the elements here, okay, and I search for 30, it would tell me that 30 is found in this list at position 3, right? And if I run it again for the unsuccessful case, I can just write the values like this, and I can search for 78, and it will say 78 not found in the list. So that is the way you can perform the linear search. Linear search is simply that you start from the beginning and you traverse each element of the list, and if the element is found, you just print that element at the position. Otherwise, you print a message that element was not found in the list. So next we can work with the binary search algorithm. We can work with how to write this program using lists in Python, the concept of binary search, right? Well, let's pick up this program, save as binary search, right? So just modify this message here. Binary search, right? Now, what is the idea behind binary search? Oh, obviously, it's not similar to linear search. So in the binary search, if I just discuss the things with you, suppose I have a list like this. Like this. So the first requirement of binary search obviously is that the list should be sorted, right? The list should be sorted. So the first step would be to create the list and then to sort it, right? Once sorted, then what I can do here is, so I'll show you the sorted list now, something like this. Okay, then I'll assign a variable. This I would refer to as the beginning and this index as the end, right? Like you've already discussed this concept in data structures course that you've learned in the previous semester. Just a recap of that, you need to mention the beginning and the end parts, and then you calculate the mid, right? And this binary search is based on the concept of divide and conquer. That is, you divide a bigger list into a sublist and that sublist into another sublist till the time you actually find the item in the list or you are sure that the item is not present in the list. So then you find the mid, right? So once you found the mid, okay, then you check whether the item is present at the mid position or not. If not, you check whether the item is towards the left or it's towards the right. And then you keep on dividing the list till the time you come to the conclusion whether the item has been found or whether the item is not present in the list, right? So this is about binary search. Now let me write the program for you. The initial part remains the same, how many elements, and then this item which needs to be searched. Then you can do a quick sorting sort of thing here with the sort method. Otherwise, what you need to do is that you can also write a sorting code on your own, which I discuss next with you. Right. So otherwise, just to check the working of binary search, I can just use this sort method here to sort the list. So I have taken the list, I have inputted the item which needs to be searched, and then I have sorted the list, right? Then how do we go ahead with binary search, right? So what I can do here is I can use a while loop here, while. So you see, our search would be unsuccessful the moment beginning becomes greater than end. Remember this thing, beginning can never be greater than end. So in our search, if a point comes like where beginning becomes greater than end, then that means that is the end. We don't need to search any further, right? So we can base our logic like this: while beginning is less than or equal to end, one condition, and uh, I can write here L mid is not equal to item, right? I can write these two conditions, right? And obviously, I need to do all that initial housekeeping as beg is equal to 1. Okay, I'll use 1 as the index, right? So maybe I can, just for simplicity, I can use 1 as the index. So I can write here 1 comma n plus 1, so that I store my list from index 1, right? So I can write beg is equal to 1 and end is equal to, say, n, right? Okay, and then I need to find the mid of these two. So I can write something like beg plus end, and I can do a floor division here. So this I have found the mid, right? And then I can check whether the item lies towards the left or the right. That can be done with this if condition, that if item is greater than, say, what is the L, right? L of mid. Okay, so you see this, if the item that I'm looking for is greater than mid. Okay, so let's understand this point. Suppose I have a list like this. Okay, so mid would obviously come as this point, right? This would be the mid. The 5 elements are there, so we'll come with mid as the middle one. So if I'm searching for an item, say 28, so it is towards here. So the logic is, if item is greater than the middle value, then what would happen? Initially this is your beginning and this is your end, and somewhere here is your mid. So if the item is towards this side, towards the right, okay, then your beginning will change, okay, end will remain as same. So then you can write something like beg is equal to mid plus 1, okay, and then you can write here else. You can use another if here. Okay, let's write else. If item is less than L mid, okay, in that case we'll see that end would change. End is equal to mid minus 1, right? I think we can, and then obviously we need to calculate with this, the value of either beg or end would change, and we need to calculate the mid again, right? So we can calculate the mid again here. Okay, so mid is this. Now the rest of the things would be controlled by this while loop, because beg and end will keep on changing. Okay, and if the item is found, this condition will become false and the while loop would end. If at some point item is not found and beginning becomes greater than end, then the condition would fail from here and the while loop would end, right? So once we come out of this, okay, so we can just check here that if L mid is equal to item, okay, then we can print. We'll just do a fast track printing here, say found, else we can say not found, right? I hope the code is all right. Okay. So we have n, we have the values in this, then we sort it, and then we calculate mid, right? Then the condition. So item greater would mean towards the right. So beginning changes, end changes, and then we calculate mid here again. So if L mid is equal to item, we see, right. Let's check this. How many elements? Say 5. Okay. What is the problem? We have not initialized the list, right? So I can initialize the list as this, right? 5 elements. So item to be searched, say 56. So we say item is found. So that way it's working all right. Let's have another run so that we are sure that it's working all right. Then we can check whether it functions as per our wish. Say 51, 34. Right. So let's search for 56 now. Not found. It's working like this. So let's have a detailed this thing now here. I can just print the list here. This message here. Sorted list is right. And then I can write, say here, print item found at position. Then I can write maybe mid here. And I can write something like item not found, right? Let's run it now. Another data. So let's search for this. Yeah, so it says position 3, right? So we need to mention, we need to make it like something like this, right? Okay. Now it would be okay. So let's take 6 elements. Enter item to be searched, let's say 20. So this way we can see that the binary search can work. So just remember this, that you need a sorted list for binary search, and then you keep on dividing the list into sublists and try to conquer it. Otherwise, if at some point the beginning becomes greater than end, then your search ends and your search is unsuccessful, right? So, all right, that's about the binary search algorithm. And let's now discuss a new topic, that is strings in Python, right? So I'll be discussing strings. Strings in Python, you see, can be initiated by using the string class, okay? And otherwise also you can, you have other syntax also for initiating or initializing a string, right? And strings are immutable in Python. That means you cannot alter them, okay? They are immutable. Okay. Then you have some inbuilt functions like list. We have some inbuilt functions with strings also, len, min, max. The similar way the index operator is there to pick up the various elements of the string. You can traverse a string with the for and the while loops. Then the string slicing and step size, it's there. String operators are there. Then there are a lot of string functions. We have the bool and the substring functions. Then we have the string conversion functions. We have the functions which can strip some unwanted characters. Then there are string justification functions. Okay, we may not be able to discuss all the functions today, but I'll just start this topic so that you can understand how strings can be worked upon in Python. For that, I'll again start this session. I'll just close this window from here and start a fresh IDLE session. Okay, another one is open. Yeah. So what you can do with strings is you can write something like s is equal to string, okay, to create an empty string. Okay, so if you see the type of this s, so you are using here the constructor of the str class, which is there in Python. Okay, this way you can create a string, or you can also create a string like this, like this. Okay, you see here, if you see its type, it's a string class. It belongs to a string class. It's a string. Directly also you can create a string like this, okay, an empty string or a string with some value. Okay, so even if you see it here, the type is again the class string. Okay, and by the thing that string is immutable in Python, kindly have a look here. Say if I just check the index of the third element of the string. So as usual, the first index is 0, then 1, then 2, and then 3. So S of 3 should be the character G. If I try to assign something to it, okay, if I try to change it, say if I try and do like this, that S of 3 is equal to D. So it will tell you that string object does not support item assignment, meaning that string is immutable in Python. Right. Now, what is the effect of that on the memory concerns for a string? So let's have a look here. Say one string is Ajay, okay, another string is Sharma. These are two different strings, right? So if you check, if you write like this, A is B, obviously it will tell you false because they are different objects in memory. How you can check it? You can check it with the ID command. So ID of this and ID of this. So these are two different IDs. But what if I write something like, say, A as Ajay and B as again Ajay? That is two strings having similar content. So obviously these are equivalent and also they refer to the same object in the memory. Since strings are immutable, so this type of mechanism is there in strings. So if I write here A is B, it would be true always. And if I check the ID for A and B, it would be the same. Right? Because once you've assigned a string A and B, if the content is same, the same object is assigned to both A and B, right? And since you cannot change A and B, so there is no problem. Whereas in lists, if you have two lists to begin with, initially they have the same content, even then they cannot point to the same object because a list can alter later on and we need to disassociate this pointer from there, right? Okay. So remember this, and if I check like A is equal to B, obviously that would be true. So strings, these are equivalent, and A is B is also true. That means strings having similar content, they are the same object in the memory and they have the same IDs. You can check here. Okay, you can check the IDs here. Right. Then next is the index operator, the len and the max and the min function. So you can just check, say len of A is 4. If I check for min A, so it would be A based on the sky value. If I check for max A, it would be Y, right? Okay. And one thing more here, we have the index operator. We have just seen that. We can also check for the negative index here. So A of -1 would be Y, A of -2 would be A, and so on, right? And then we can just do some string slicing like we did in the lists. We can do some string slicing also, like we can do here. Say I can take a bigger string, say S equal to so length is 21, and then I can do some slicing here, say S5 colon. That would mean starting from the fifth index and going till the end. The end is not given. So fifth index is 0, 1, 2, 3, 4, 5, A. So it would be like this. Okay. Similarly, if I write here colon 6, that would mean from starting to index 6, right? Then I can pick up some slice here, 3 colon 5 colon 4. Okay, so you can see the slice has come up like this. So starting from third index, yeah, right. So if we look at here, then starting from third index, going on till fifth index, and fifth not included. So we cannot go in steps of 2. So only one character is displayed. So if I can just modify it here, I can pick up a bigger value here to see more characters, right? So step size 2 would be like, we need to skip one character, right? Similarly, we can also check for this starting from the reverse. Okay, so this would print the entire string, but not the first character. We are saying from end till beginning, but obviously beginning is not included, right? So this P is not printed, right? With this. Okay, that's the reverse. Okay. You can see this is the reverse of this, but minus the initial character. And if you want a reverse, otherwise the complete reverse, you can write something like this, right? So this is the string slicing. Then we can use the plus and the star operators just like we did in list. So if I write here s star 2, you can see it's a repetition, programming in Python twice. If I write it s star 4 like this, then to concatenate two strings, I can use plus. So let's see whether A is still there, S is still there. So if I write here A plus S, you can say both these strings are concatenated. And then I can check something like A in A, right? I need to mention this as a character, right? So it's true, right? A is present in this string, Ajay. But if I use something like a capital A here, and answer obviously is false, right? Similar to list, just see that, okay. And then the is operator we have already seen, like if two strings have similar content, then is operator returns a true value, right? So I think that is all for the strings part, because I need to discuss the RDBMS also with you. And we've reached 48 minutes time in the class. So I'll just end this lecture here on Python, and you can just practice the programs on list and you can start working with strings in Python. In my next class on Python, I'll be discussing the string functions in details, and we would be covering some more programs on lists and strings. Till that time, just keep watching my videos. Thank you very much.